Okay, this is Calculus 1, Lesson 10. And today is the lesson on the product and the quotient rules for derivatives. Before we start, are there any questions about homework problems or about anything we've done recently? Last week or before? Any homework problems you would like me to go over?
Professor, I have one. Just give me.
Yeah, go ahead.
Yeah, I need to find which one it was again. What question was it again? I believe it was question 61 on lesson 9. Or you can do that. Thank you.
So this was finding a horizontal tangent line?
Yes, please.
Okay. So this is section 2.3, number 61. And we have the function y equals x to the fourth minus 2x squared plus 3. And we want to find the points at which the graph has a horizontal tangent line. Now, if you have a horizontal tangent line, that means the slope of the line is 0. So you want to find the points x or xy such that the slope of the tangent line, what is the slope of the tangent line? It's the derivative, such that dy dx equals 0. So for this polynomial, dy dx is 4x cubed minus 4x, which is 4x times x squared minus 1, which is 4x, x minus 1 times x plus 1. And this equals 0 precisely when x equals 0, x equal 1, or x equal minus 1. And when x equals 0, y is equal to 3. When x equal 1, you get 4 minus 2, y is equal to 2. When x is minus 1, you get 1 plus 3 is 4, you get y equal to again. So on the graph of this function, you have a horizontal tangent line at the point 0, 3, 1, 2, and 1 minus 2, and minus 1, 2. In fact, the graph of this is going to look something like that. But these are the points these are the 3 points where the graph has a horizontal tangent line. Okay. Any questions about that?
Thank you, Professor.
Any other questions about homework problems? Let me just remind you that today, which is Monday, the 8th, we do lesson 10. Wednesday, the 10th, we do lesson 11. Next Monday, the 15th, lesson 12 is review. And Wednesday, the 17th, which is the 13th class, is the first exam. So the first exam is a week from Wednesday following the syllabus. And again, that we remind you, the way the exam will work is at 11 o'clock, I will post the exam on Blackboard, also email it to everyone. And by 1 o'clock, so it's more than more than the allotted time, but that's because there's some technical issues you always deal with. You have to have made a PDF copy of your exam, what you've written out on paper, and upload it to Blackboard. So the exam will be distributed by email and on Blackboard, and you submit the PDF copy file of your exam to Blackboard.
I'm sorry, you said 11 o'clock, the exam will
Sorry, 1
start?
o'clock. Yeah, excuse me, 1 o'clock.
Okay,
1 to 3, just like the class time, basically.
all right, thank you.
1 to 3.
Yeah, so in class. So instead of to 2:40, because it takes a few minutes to convert a file to PDF and so forth, you have until 3 o'clock.
And there will be how many questions? Like 10, Professor, or 20?
Approximately,
Okay.
yes. Okay. All right, so the lesson for today, we have two more basic, well, three if you like, basic techniques to learn about how to differentiate a function. And today we do the product rule and the quotient rule. And on Wednesday, we do the most important rule, which is something called the chain rule. So what is the product rule? So the product rule for derivatives. And what the product rule means is we have two functions, f of x and g of x, and we multiply them. So this is their product. And the question is there a way to calculate the derivative of the product of f and g if you know separately the derivatives of f and g? And the answer is yes, it's very pretty. It's the function f times the derivative of g plus the derivative of f times g. All right, so that's the product rule, but all right, I will prove it, but let me just work a few examples of using the product rule before we start. So these are some examples. So suppose we have to differentiate the function h of x, which is 3x minus 2x squared times 5 plus 4x. So now, so if you look at this, you can see easily this is a product. It's like you take f of x to be 3x minus 2x squared and g of x equal 5 plus 4x. And then you see h of x is the product f of x times g of x. What are the derivatives of these functions? If this is f of x, the derivative is 3 minus 4x. This is g, the derivative is 4. So the derivative of h of x, it's f, 3x minus 2x squared, times the derivative of g, plus the derivative of f, times g. And then you just need to expand this and work out what it is. This is 12x minus 8x squared plus 15 minus 20x plus 12x minus 16x squared. So minus 8 minus 16 is minus 24x squared. 12x plus 12x is 24x. Minus 20x is plus 4x. And 15 is 15. So that's the answer.
Professor, where did you get the minus 20?
Minus 4 times 5 is minus 20.
So
I'm just
what about
expanding.
what about 3 times 4? You didn't do that, or you jump on it? No, I see.
What 3? You mean here, 3 times 4?
No. You jump
Here?
on it, yes.
Or
You
here, 3 times 4 is 12x.
I see.
Now, you can expand this any way you like, but you always get the same answer. Okay. Any other questions about this? Suppose y is x e to the x, and we want to find dy dx. So again, you can look at this as a product. It's like you have f of x equal x and g of x equal e to the x. So the derivative of the product is f, which is x, times the derivative of e to the x, which is e to the x, plus the derivative of x, which is 1, times g, which is e to the x. Or if you factor out the e to the x, you get x plus 1 times e to the x.
Professor, I don't get this. Can you explain one more time, please?
Sure. So we want to differentiate. So y is x e to the x. That's our function. And the problem is to find the derivative. Okay? So I can't just write down what the answer is because I don't know. But I say I can look at this as a product. If I let f of x equal x and g of x equal e to the x, that means that y, which is x e to the x, is exactly the product of these two functions. F of x is x and g of x is e to the x. Now f prime of x, the derivative of x is 1. And the derivative of e to the x is e to the x. So dy dx is the derivative with respect to x of, let me just write it as f of x, g of x, where this is f and this is g. By the formula, this is f of x, g prime of x, plus f prime of x, g of x. F of x is x. G prime of x is e to the x. F prime of x is 1. G of x is e to the x. And I factor out the e to the x, that's just x plus 1 times e to the x.
Thanks.
Let me do another example. Suppose y is sine x cosine x, and I want to differentiate it. So I can think of this as f of x, g of x, where f of x is sine x, g of x is cosine x. I know the derivative of the sine is the cosine. I know the derivative of the cosine is minus the sine. So dy dx is f of x g prime of x plus f prime of x g of x. F of x is sine x. G prime of x is minus sine x. F prime of x is cosine x. G of x is cosine x. So what I have is minus sine squared x plus cosine squared x, or cosine squared x minus sine squared x. I just rearranged it. And this you might recognize as the cosine of 2x. Okay. So for completeness and mathematical integrity, I should prove the product rule. So this is the proof, the product rule. The derivative of f of x times g of x, by definition, is the limit as delta x goes to 0 of x plus delta x g of x plus delta x minus f of x g of x divided by delta x. That's the definition of a derivative. And now we have to be a little bit clever. I have delta x in the denominator, and in the numerator, I have f of x plus delta x, g of x plus delta x. We'll leave a space, minus f of x times delta x. So this is the same as that. I just left a space in the middle. And what I want to put in is 0. You can always add 0. But I'm going to put 0 in the form minus f of x plus delta x g of x plus f of x plus delta x g of x. So this is just 0 minus something plus itself. And this is the limit as delta x goes to 0. From these first two terms, I can factor out an f of x plus delta x, and I have g of x plus delta x minus g of x. And from the last two terms, I can factor out a g of x. I have f of x plus delta x minus f of x times g of x. So this is just a little algebraic manipulation. This is the limit as delta x goes to 0, f of x plus delta x times this fraction, g of x plus delta x minus g of x over delta x. And then here, I have f of x plus delta x minus f of x over delta x times g of x. And as delta x goes to 0, f of x approaches f of x plus delta x approaches f of x. This is just gives you the derivative of g. This gives you the derivative of f times g of x. So there is a completely rigorous proof of the product rule. Again, it's not the proof that you have to know in
Yes,
math. Yeah, go ahead.
will you give this the exam?
Will what be on the exam?
This proof.
I said the proof is not on the exam. Every time I give a proof, I say this. I say that you have to know how to use the product rule. You have to have seen the proof, so you know it's not just some arbitrary invention. It's something that's true. But what you have to know is the use of the product rule, not the proof. Let's do another example. Suppose y is 2x cosine x minus 2 sine x. What is dy dx? Well, it's the derivative of this difference. That's the derivative of 2x cosine x minus the derivative of 2 sine x. This is a product. This is the product of 2x times cosine x. So by the product rule, this is 2x times the derivative of cosine x, which is minus sine x, plus the derivative of 2x, which is 2 times the cosine of x, minus the derivative of 2 sine x is 2 cosine x. These cancel, so we're left with minus 2 x sine x is the answer. So here, just so you have some practice, suppose we let y be equal to the square root of x sine x. Find dy dx. So spend a minute or two working on that. Can someone tell me the answer? Let's see. So this is a product of two functions. You can think of this as f of x times g of x, where f of x is the square root of x, which is like x to the power 1/2, and g of x is sine x.
Yes, sir.
So the derivative of the square root of x is 1/2 x to the minus 1/2, or 1 over 2 times the square root of x. And the derivative of the sine is the cosine. So for this function, y equals square root of x sine x, dy dx is f of x times the derivative of the sine plus the derivative of square root of x, 1 over 2 root x, times the sine.
I got it.
And that's the answer. Okay. So that's the rule for differentiating the product of two functions. What about the quotient? So suppose we have a function y equal to f of x divided by g of x, and we want to find dy dx. That is the derivative of the quotient f of x divided by g of x.
Minus, right? That would
And
be minus.
the quotient rule says the following. It's a quotient. The denominator is the denominator g of x squared. And it's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So this is more complicated than the product rule. So that's just a fact of nature. It is more complicated, but that's what it is. And you have to know it. So here are some examples. Suppose y is equal to 5x minus 2 divided by x squared plus 1. So this is of the form f of x divided by g of x, where the numerator is 5x minus 2. The denominator is x squared plus 1. Now, the whole thing is you have to be able to differentiate the numerator and the denominator. But these are easy. If f of x is 5x minus 2, the derivative is 5. If g of x is x squared plus 1, the derivative is 2x. So dy dx is equal to what? Well, it's the denominator squared. G of x is x squared plus 1 squared. And the numerator of this derivative is the derivative of f, which is 5 times the denominator minus the numerator times the denominator, the derivative of the denominator, which is 2x. So this is, when you expand it, 5x squared plus 5 minus 10x squared plus 4x. So this is equal to minus 5x squared plus 4x plus 5 over x squared plus 1 squared. And there's no real secret to these things. It's just a matter of doing everything carefully. Here's another example. This is the way the problem is stated in the text. So let me just write the quotient rule here so it's on the same page. The derivative of the quotient is the quotient with g of x squared in the denominator. The derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. So here's a problem. Find the equation of the tangent line to the graph of the function f of x equals 3 minus 1 over x plus 5. And when x is minus 1, this is 4 over 4, which is 1. So at the point 1 comma 1. The point 1 comma 1 lies on this curve. If you just do the calculation, you check. F of minus 1 is 1. So I want to find the derivative of this. And the numerator is already a little bit complicated, but I can simplify. Because f of x, which is 3 minus 1 over x plus 5, if I multiply the numerator and the denominator by x, in the numerator I get 3x, and x time over 1 over x is 1, so I get 3x minus 1 over x squared plus 5x. So here I see I can make things a little bit easier if I rewrite this in this form. And now what is the derivative? It's the denominator squared. And what do we get in the numerator? We get the derivative of this numerator. The derivative of 3x minus 1 is 3 times the denominator.
So
Minus,
why did you multiply by x?
over here,
Oh, yes.
I just simplified this. Because here, this 3 minus 1 over x, that's a little bit complicated to differentiate, but when I multiply the numerator and denominator by x, which I'm allowed to do, you can always change a fraction by multiplying numerator and denominator by the same thing. I get rid of this 1 over x, and this just becomes 3x minus 1 over x squared plus 5x. So, after you've worked on, 100 problems, let's say, you develop the technique to see what to do to simplify the problems to get the right answer quickly. So this is just a choice to simplify. This function can also be written like this. And when I apply the quotient rule to this, it's the derivative of the numerator, which is 3 times the denominator, minus the numerator times the derivative of the denominator, which is 2x plus 5. So let me simplify this. Let me expand the numerator. I get 3x squared plus 15x minus what I get when I multiply these two terms together. I get 6x squared plus 15x minus 2x minus 5. 6x squared 15x minus 2x minus 5. So it's this minus this. So 3x squared minus 6x squared is minus 3x squared. I have 15x minus 15x plus 2x. And I have minus minus 5. So f prime of x is equal to this.
Professor, I got a question.
Yes,
How did you get x? I understood how you got x2 plus 5x, but why did you add the extra exponent 2 after?
what are you looking at? Which line?
You see the function at the end before doing the prime of x,
Here?
3x, yeah, 3, you see 3x, the last one after
Yeah.
that. Yeah.
Down here?
Yeah, I understand how you got that, yeah, but then you put an extra exponent 2, how?
Where, when I went from here to here?
No, 3x minus 1 over x2 plus 5x, what you pointed at last.
3x minus
Yeah.
1 over x squared plus 5x?
Yeah, and the next one, for the 5x, you put a,
I mean, when I get from here to here?
yeah.
Well, here's the function and here's the derivative. I'm differentiating. This is the derivative of this function. So you square the denominator. That's the quotient rule.
Oh, okay.
You square the denominator, and it's the derivative of the numerator, which is 3 times the denominator, minus the numerator times the derivative of the denominator. And then I expand all this, collect the terms, and simplify. And this is what I get. And when I evaluate this at x equal 1, I get minus 3 sorry, when I evaluate this at minus 1, that's what I'm asked to do, I get minus 3 times minus 1 squared plus 2 times minus 1 plus 5 over minus 1 squared plus 5 times minus 1. I'm just putting down sort of more detail than I ever need. Minus 1 squared is plus 1. This is minus 3. 2 times minus 1 is minus 2. Plus 5. Here I have 1 minus 5 minus 4 squared. I get 0 over 16, which is 0. So the derivative at minus 1 is 0. So the tangent line is just the horizontal line through the point 1. So the tangent line is just y equal 1. On this curve, here's the point, minus 1, 1. The tangent line is horizontal through that point. It's just the line y equals 1. You know, so take a minute or two, look at this to see if there are any questions about it. But this is also a problem that I took directly from the book, so it's also written out there very neatly and cleanly and easy to see.
It's y equal minus 1 or 1.
Y equal 1. This is the point minus 1, 1. So on the x-axis, this is minus 1. On the y-axis, this is 1. This is the horizontal line, y equals 1. Right? This is the line, y equals 1, if this is the x-axis. So let me, again, for honesty in mathematics, let me sketch the proof of the quotient rule. If any of you are thinking about being math majors, this is exactly what you have to learn when you take advanced calculus and thereafter. So I have a quotient of two functions, f of x over g of x. Of course, I'm only doing this where the derivative, where g of x is non-zero, and I want to find the derivative. So by definition, this is the definition of the derivative. It's the limit as delta x goes to 0 of f over g evaluated at x plus delta x minus f of x over g of x divided by delta x. And these are just fractions. So you have to be able to deal with fractions, of course. If I multiply through by g of x times g of x plus delta x, I get f of x plus delta x g of x minus f of x g of x plus delta x divided by delta x times g of x times g of x plus delta x. And this is the limit as delta x goes to 0. Again, I'm going to put another term in the middle here, just basically going to add 0, put in a nice way. Right here I have f of x plus delta x g of x. Here I have minus f of x g of x plus delta x. I'm going to subtract f of x g of x and add f of x g of x. So I'm just adding and subtracting the same thing, which is always legitimate. So this is the limit as delta x goes to 0. I'm not changing this denominator. From these first two terms, I can factor out the g of x. I get f of x plus delta x minus f of x times g of x. And from the last two terms, I can factor out an f of x. And I'm going to actually factor out a minus f of x. So then I have g of x plus delta x minus g of x. So this is just high school algebra, if you like. A little bit complicated, but nothing more than that. And I'm going to write this as the limit as delta x goes to 0. Here I have g of x plus delta x. And I also have f of x plus delta x minus f of x divided by delta x times g of x minus f of x times g of x plus delta x minus g of x over delta x. And again, you just have to check carefully and take some time that all the algebra is correct. And now what happens as delta x goes to 0? I have g of x, as delta x goes to 0, x plus delta x goes to x, I get g of x squared. This is the derivative of f times g minus f times the derivative of g. And voila, I have proved the quotient rule. Again, everything is done neatly, legibly, carefully, and correctly in the book. Now, we can use the quotient rule to fill in some gaps of previous work. So we proved for a positive exponent n, the derivative of x to the n is nx to the n minus 1. And I stated this is true for negative numbers n, and I just stated it. So suppose I want to prove this for negative numbers. I can now do it using the quotient rule. So suppose let n be negative, and if it's negative, you can write n as minus k, where k is a positive integer, right? I mean, every negative number is minus some positive integer, like minus 2 is minus 2. So if n is negative, what is the derivative of x to the n? That's the derivative of x to the minus k. X to the minus k means 1 over x to the k. So I can write x to the n as a quotient, and now k is a positive integer. By the quotient rule, this is the denominator squared, the derivative of the numerator times x to the k minus the numerator times the derivative of x to the k. So here I have in the denominator x to the 2k. The derivative of 1 is 0. The derivative of x to the k is k, x to the k minus 1. So this is minus x to the k minus 1 over x to the 2k. This is minus k minus 1 minus 2k x to the minus k minus 1. Right? This is just the rules of exponents. I mean, if you have a question about this, really spend a lot of time at home thinking about it. And finally, oops, forgot the k. And minus k is n, and minus k minus 1 is n minus 1. So the derivative of x to the n dx is nx to the n minus 1, also for negative integers n. We can also now find the derivatives of all of the trig functions. Remember, we proved that the derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. But what about the tangent, the cotangent, the secant, and the cosecant? Well, what is the derivative of the tangent? We can write the tangent in terms of sine and cosine. The tangent is sine x divided by cosine x. And now we can use the quotient rule. It's the denominator squared, the derivative of the numerator, which is cosine x, times the denominator, minus the numerator times the derivative of the denominator. Derivative of cosine is minus the sine. So this is cosine squared x, minus times minus is plus, sine squared x. You must never forget that for any angle x, cosine squared plus sine squared is 1. So this is 1 over the cosine squared, or 1 over cosine x squared. And another name for 1 over the cosine is the secant. So we have that the derivative of the tangent of x is secant squared x. And we can work out the derivatives of the 3 other trig functions. What about the secant? What's the derivative of the secant of x? Well, the secant is 1 over the cosine. If you differentiate using the quotient rule, you get cosine squared x in the denominator. In the numerator, you get the derivative of 1, which is 0 times the cosine, 0, minus the derivative of the cosine, which is minus the sine. Minus times minus is plus. So this is sine x over cosine squared x. Or you can write this as sine x over cosine x times 1 over cosine x. Cosine times cosine is cosine squared. This is the tangent. This is the secant. So the derivative of the secant is the tangent times the secant.
Question, Professor.
Yeah.
Why did you write 0 minus sine of x? So the one is the first function, right?
Yep.
Is
F of x
the,
equals 1,
yeah,
and prime of x is 0.
0, yes. So what about g of x? So it's should be f of x times g of f, x, right?
So you would get, so f prime of x, g of x in this case, would be 0 times cosine of x, and 0 times
So
anything
you
is
went
0.
directly. Okay, I see. Jump on it.
Yeah. Yep, exactly. And we can also find the derivatives of the cotangent and the cosecant. Right? I'm just not going to write them out, but the derivative of the cotangent, derivative of the tangent is secant squared. The derivative of the cotangent is minus the cosecant squared. The derivative of the secant is tangent times secant. The derivative of the cosecant of x is minus the cotangent times the cosecant. So now you have the derivatives of all 6 trigonometric functions. So let's do a few more examples. Suppose f of t is f of x is sine x over x cubed. What is the derivative? Well, the denominator is going to be x cubed squared, which is x to the 6th. And the numerator will be the derivative of the sine times the denominator, x cubed, minus the sine times the derivative of x cubed, which is 3x squared. That's what it is. if h of x is 2e to the x cosine x, and we want the derivative of h prime of x, we use the product rule. It's 2 times the derivative of e to the x, which is e to the x times cosine x, plus 2e to the x times the derivative of the cosine, which is minus sine of x. Or if I factored out 2e to the x, it's that times cosine x minus sine x.
Professor.
Yeah,
So I don't know why did you use this formula.
which formula are you talking about?
This one, like this should be the multiplication formula. It should be plus, right? You said minus.
It is plus, so the second term is plus 2e to the x times the derivative of cosine, which is minus the sine. So 2e to the x times minus sine x is minus 2e to the x sine x. The minus, it is plus because it's a product rule, but the derivative of the cosine is minus the sine. So you get minus there.
So what is the formula for the product rule again? It's
F of x, g of x, the derivative of this product,
I cannot say it, please.
it's f prime of x, g of x, plus f of x, g prime of x.
Professor, I'm not sure if you wrote this before. You said before it was f of x
Which is
times.
but you know that a plus b equals b plus a, right? So this is the same as f of x, g prime of x plus f prime of x, g of x.
Yeah,
It's exactly the same thing.
but this
right?
one won't work on the division. I said this one cannot work on the division.
They're the same. They all work. There's no difference. This equals this. What doesn't
Yes.
work?
All right.
I mean, it has to work. It's the same formula. If you write 1 plus 2 or 2 plus 1, it's still equal to 3. So if you're a sum, you can, for anything, a plus b equals b plus a. This plus this or in the other order, it doesn't matter.
Yes, but I'm talking about the division formula. So we cannot use, we cannot switch it, right?
Well, in the division formula, there's a minus sign.
Exactly.
A
So
minus b is not
Yes.
the same as b minus a.
right. So that's what I'm saying.
Right. But this is not the division rule. This is the product rule.
All right. Yeah. So here the order doesn't matter.
Well, right,
Right.
because
And
yes, for the product rule, it's a sum, so it doesn't matter.
So okay.
Okay. Now, there's one more thing that's important to note in this section. And if you're in my Maple class, this will be in the next lesson, is what are called higher order derivatives. Suppose we take the function f of x. And when you differentiate it, f prime of x, f of x equal x cubed, say. And when you differentiate it, you get 3x squared. Now, suppose you take the function g of x equal 3x squared. When you differentiate that, you get 6x. But of course, what you're really doing is you're taking f, you're differentiating it once to get 3x squared, and then you're differentiating it a second time to get 6x. So you can also say that if you take f and you differentiate twice, I'll put 2 bars there. The second derivative is 6x. So we can call this the first derivative, and this is the second derivative. And if I let h of x be 6x, if I differentiate that, I get 6. You can also say if you take this function f of x and you differentiate it 3 times, you get 6. So in general, if you have a function, you can differentiate, and then you can differentiate the derivative, and you can differentiate the derivative of the derivative. You can keep differentiating. And if it exists, doesn't always exist, the nth derivative of y equal f of x,
Is 0?
no, is the function obtained for any function by differentiating f of x n times in a row. And the notation, again, just the way there's a lot of notation for derivatives, the nth derivative can be written as dnf dx to the n, or f superscript n in parentheses x, or, well, these are the two most common. And for small numbers, first derivative f1 of x, we often write x prime, second derivative f double prime, the third derivative f triple prime, but you don't want to keep doing that, or you'd end up with, you know, a million primes. It doesn't make any sense. So for the first, second, or third derivatives, you can use this prime notation, but for higher derivatives, we would use this or this. So for example, if f of x is x sine x, the first derivative by the product rule is sine x plus x cosine x. You should just do this yourself to check this is correct. The second derivative, differentiate the sine, you get the cosine. Differentiate x sine x, you get another cosine, plus or minus x sine x. So this is 2 cosine x minus x sine x. The third derivative, you differentiate again. The derivative of 2 times the cosine is minus 2 times the sine, minus the derivative of x sine x. So the derivative of x sine x, well, I already did that actually. Here it is. It's sine x plus x cosine x. So this gives me minus 3 sine x minus x cosine x, and so forth. I could keep on differentiating if I want. So here's another example. Let f of x equal 3x squared minus 5x plus 1. Compute the fourth derivative of this function. So I'll give you a minute to do it yourselves. You have to compute the first derivative, then the second derivative, then the third derivative, and then the fourth derivative. So do the exercise and tell me the answer.
Professor,
Yeah.
I think even the third derivative is 0.
So I asked, what's the fourth derivative?
0 too.
Exactly. So 3x squared minus 5x plus 1. The first derivative is 6x minus 5. You differentiate this, you get 6. You differentiate 6, you get 0. And you differentiate 0, you get 0. So this is the fourth derivative.
So what is the purpose of doing this?
What is the purpose?
Yes,
What's the purpose of doing the first derivative?
I have no idea.
Well, either you find it interesting and you like to do it, or you're interested in the problem of finding the tangent line to a curve at a point, or you have a particle moving and you want the velocity. That's the first derivative. Now, the second derivative, again, if you're looking at the motion of a particle, the second derivative tells you the acceleration of the particle. And if you're looking at the curve, we'll talk about this later, but it tells you where the curve is concave up or concave down, some geometrical property. The third derivative, fourth derivative, just think of this as just an exercise in differentiating at this point. At some point, you want to know, see, when you calculate the tangent line, you're approximating a function by a straight line. But you could also try and get a better approximation by approximating a function by a parabola or by a cubic curve and so forth. And these higher derivatives are used, among other things, to take a complicated function and to try and get a good approximation by a polynomial. But for us, it's to think of this as just an exercise in learning the skills to differentiate functions. But within mathematics, these are useful things. Here's another example. Suppose g of x is e to the x over x. Compute the second derivative of this function. And while you're doing that, I will
Professor, I cannot say it. You said x over x?
e to the x over x. The exponential function e to the x divided by x. Let's see, Amin, Manon, Negron, Leonardo, Lopez, Atkins, Gordon, Bello, Fletcher, Lozano, Reyes, Reyes, Beltran, Segura, Malanuevo, Soto, De La Cruz, Vega, Garcia Vega, Tanwo, Alcantara, Wiley, One Diamond Tego, Al Coffee, all right, well, let's see. This is g of x by the quotient rule. The first derivative, you take x and you square it, and the derivative of the numerator is e to the x times the denominator minus the numerator times the derivative of the denominator, which is 1. So this is the first derivative. And what is the second derivative? So it's x squared squared in the denominator. And in the numerator is the derivative of the numerator, the derivative of x e to the x minus e to the x. So the derivative of x e to the x is 1 times e to the x plus x e to the x minus e to the x. Well, that times the denominator minus the derivative of the denominator times the numerator. So here we have x to the 4th in the denominator, x squared squared. I have e to the x minus e to the x, they cancel. So this looks like it's just x cubed e to the x minus 2x squared e to the x plus 2x e to the x. Or if I wanted to factor x e to the x out of the numerator, it would be x e to the x times x squared minus 2x plus 2. And then x over x to the 4th is x cubed. And so again, if you need to really check that this is correct, I wouldn't leave it like that. I would go back and do the whole problem again and just double check that I didn't make any mistakes. And then you're done. Let's do one more, and then we'll stop for the day. Suppose we have f of x equals 2 minus 2 over x. Find the third derivative. Okay. So let's see. So f of x, I could write this. I could use the quotient rule, but it's a little bit more complicated than it needs to be. This is really 2 minus 2 times x to the power minus 1. So the first derivative, the derivative of 2 is 0, and the derivative of x to the minus 1 is minus 1 times x to the minus 2. Minus times minus is plus. This is 2x to the minus 2. The second derivative is 2 times the derivative of x to the minus 2, which is minus 2x to the minus 3, is minus 4x to the minus 3. And then the third derivative is minus 4. The derivative of x to the minus 3 is minus 3x to the minus 4. Minus 3 times minus 4 is 12. X to the minus 4 is 1 over x to the 4th. So that's the answer. All right, so this is lesson 10. This is all we're going to do today. I would really urge you to work through the examples in the book and do as many homework problems as possible. On Wednesday, lesson 11, we do the chain rule. And the chain rule is the most complicated, but also the most useful differentiation formula. So you're really going to need to do a lot of problems on the chain rule as well, because the exam next week will be mostly, not entirely, but mostly a list of functions, and you have to find their derivatives. So that's the story.
Professor,
Yes,
will you provide a study sheet, please?
a review sheet, yeah. Yeah, I'll send it out over the weekend and go over it on Monday.
Thank you very much.
All right. Any other questions before we quit for the day?
Professor, I have a question. Which lessons will be in exam 1?
Everything since the beginning, lessons 1 to 11.
Okay, thank
But
you.
every exam is cumulative.
Professor, that's a lot.
What's a lot?
1 to 11, you said?
Well, when you take the final, it's on the whole course. So you have to know everything. I mean, what else would you think the exam would be on? We can't ignore any of the lessons. You have to know it all.
Right.
Right? So the answer to the question, what's on the exam, is everything on the syllabus. It's not going to be one question from each lesson, but you have to know everything in all the lessons.
Okay.
And as I told you, most of the exam will be finding derivatives of functions, and there will always be quite a question involving velocity and acceleration, when you drop something from a building, that kind of problem, and also calculating the tangent line to a curve at a point. You have to know that. Okay. Let's see. Today's Monday, so nice outside. Don't forget, by the way, I think we go to daylight savings time this weekend, so you lose an hour of sleep. Don't wake up late on Monday morning and miss a class. Okay. Bye, everybody. Take care.
Thank you, Professor. Take care too.